So, so last time we were discussing AND gate and NOR gate and the basic logic gates, and we are going to discuss the last one, NOT gate. So to understand what NOT gate is, let me start with a simple circuit, right? So if you look at this simple circuit, you will have a resistor, and then you will have a switch, you have a bulb, and then you have a battery, right? Right. So in this circuit, what will happen now? Switch off the switch, then the current flow through the resistor R, right, and then through the bulb, and then because of that, so this will be on. That means when the switch is open, the bulb is on. But when you close it, what will happen? There are two paths to follow the current, right? And here through the bulb and here through the switch when you close. But then this is easier than this one because there's no resistance here. So current will flow through the easiest path and the bulb is switched off. So this is exactly what will happen. So we can say that when switch A is open, the bulb Q is switched on, right? And when A is closed, the bulb Q is switched off. So when you take NOT gate, what it provides is a complement of the input as the output. So if you think the input is 0, the complement of 0 is 1. And then complement of 1 is 0. So that's what we can represent here as well. Like in earlier, if you use the same notation for switch A and bulb Q, then what will happen? So when A is open means A is 0. Then Q is on means 1. Then the next one, when A is closed, that means when A is 1, then the Q is off, that means 0. So always NOT gate provide the complement. So if you draw the truth table for NOT gate, right? So what will have, we will have only one input. So this time we have one switch A and bulb Q. So the truth table will be when the input is 0, the output is 1. When the output is, so input is 1, the output will be 0. So always the NOT gate provide the complement of the input, right? So sometimes we will say it provide A bar, complement, we represent A bar. So if you go back, so the Boolean expression for NOT gate, so we can say that the Q, the output is always A bar. We put bar, that means we draw a line on top of A, right? So this will say that representation complement of A. So when you want to represent A bar, there's another way you can represent. You can say A dash. So for example, if you want to type the answer in the keyboard, so since you cannot represent bar here, you can use dash as well. So either you can use bar or dash. So both represents the complement or not A, right? So A means this is Q equals not A, right? That's a representation. So if you want to draw the symbol for NOT gate, it will look like this. So you will have a triangle shape, and then in front you have a small circle. So when the input is A, then output will be Q, and we can represent Q as A bar.